Well, hello, class.
Greetings, Earthling.
Greetings, Earthling.
Well, I'm glad I have all these little green people here in my class. Isn't that interesting? So, we're going to turn to solving non-homogeneous equations with constant coefficients. In other words, the right side isn't zero, it's some function g of x. That's what makes these interesting. And this is going to involve two steps. First, we're going to find what's called the complementary solution, otherwise called the solution of the homogeneous equation, as we did in the last lesson. That's going to depend on the characteristic equation, etc., and that's not too terrible hard to find out. Sometimes I'll just call it y sub c or yc. And then, after that's found, then we find what's called a particular solution, y sub p. And then once we've found this, and I'll describe how to find that using the method of undetermined coefficients later in the lesson, but once we found the yp and the yc, then our solution, our general solution is y equals that yc that we found plus the yp that we find using the method of undetermined coefficients. And essentially, the method of undetermined coefficients is make a really good guess and then make it work.
I can't wait.
Well, okay, good. So, there's some obvious limits to the method, as the differential equation must have constant coefficients and g of x must be some linear combination of polynomials, e to the a times x, sine of bx, and cosine of bx. Otherwise, I'm not saying it wouldn't work, but it would be rather tricky.
I think that this is your way of telling me something.
Yes, it is. And the way what I'm telling you is, first thing we want to do is solve the homogeneous equation for this example, and the homogeneous equation would be as if this wasn't 2x but 0. And so we'd say, well, our characteristic equation for that is m squared plus m minus 6 equals 0, and that has roots m equals negative 3 and m equals 2. So, the yc, the complementary solution, c1 times e to the negative 3x plus c2 times e to the 2x. Now, here's where the undetermined coefficients gets interesting.
Hot stuff coming up.
Yes, since the right-hand side, our g of x, is 2 times x, a polynomial function of the first degree. That means we will guess our yp is a polynomial function of the first degree, a times x plus b. So now that we've made that guess, y prime is easy to find as a, and y double prime is 0. So when we substitute back into our original equation, we get 0 plus a minus 6 times ax plus b, and that equals 2x. So we get this system of equations, negative 6ax equals 2x. You see why that has to be? The x term on the left side of the equation and the x term on the right side of the equation have to have the same coefficient. So that means a minus 6b, I'm sorry, that means negative 6a and 2 have to be equal to each other, so a is negative a third. Now, the constants also have to be equal, so a minus 6b has to be equal to 0, because there's no constant term on the right side of the equation. So a minus 6b equals 0, a equals negative a third, therefore b equals negative an 18th. So now we've got our yp, the solution of the equation is the yc, the complementary solution, plus the ax plus b that we just found with a equal to negative a third and b equal to negative 1/18. There is the solution to the equation.
I know.
Oh, good.